Okay, this part we'll learn how do we convert from truth table specification to Boolean equations. Why? Simply because we may need to have simpler specification, or we may want to wire our circuit based on, or design our circuit based on Boolean equation, or we want to simplify the Boolean equations before designing the circuit, so we'll have more optimized circuit. Let's go for the details why over here. So this gonna be converted into one, or easily explained with one example. So I want to use this example. So we'll start with a problem definition like this. Benny is having a picnic, and he only enjoys it when there are no ants and it doesn't rain. So no ants, no rains, then enjoy. But if there is ant, not enjoying. If it's rain, not enjoying. If both of them happen, not enjoying. So you will see the design circuit that will output the true only if Ben enjoys a picnic. Okay? Then from this specification, it is relatively easy for us to build the truth table. So we can build the truth table that will represent ant as A and rain as R. They are input. And if no ant, no rain, then enjoy. Okay, if no ant but it rains, I'm not enjoyed. If there is ant and not rains, not enjoyed. If there is ant also rains, not enjoyed. So this one is relatively simple to represent the business requirement like this into the truth table form. Now the question from here is, can we create a wired circuit, using this? The question is kind of, the answer is kind of relatively difficult to wire the circuit. So normally we'll perform the next task, which is to convert that into Boolean expression. Okay, so it is E equal to not A and not R. Okay, not A and not R. And this one, it's E equal to not A and not R, which is it is not the NAND gate. Okay, make sure it is not the NAND gate. It is not A, not and not R over here. Then the next question is, can we create and wire the circuit from this? And we'll say, okay, it's relatively easy right now because we want to implement not A. So this one, we're going to use the not logic gates to negate A, and we'll use the not R, which is the negative version of R. Then we'll add them together and we'll produce the E. So the answer is yes. It's better to use this Boolean equation because it helps us to perform the wiring or circuit design. The next one is, the question is, can we simplify this? Okay, it is actually yes. This one can be written as enjoyed is the not or operators between A and R. So this one is the NOR operators. So we're going to be able to just simply wire it with the NOR or not or operators like this. So we already simplify from this to this. Okay, but what the point right now is this: converting from truth table to Boolean expression helps us in several points. First, it's gonna be a simpler specification because it's shorter. Okay, let's say if you wanna have simpler specification on you produce a circuit and you wanna sell it. If you write the whole truth table, it's gonna be complicated for people to know what to do. If you write them in English only, probably it's ambiguous. So Boolean equation is a better choice. Another one is it's easier to wire the circuit because we know how to wire the circuit from the Boolean equation. The next one is it's allow the simplification using Boolean algebra that we will learn in the future. Okay, we'll use some math interpreter to simplify that we've seen over here. Like how do I simplify it from this one to this one based on what? We'll learn Boolean algebra.